Hello, I'm Michael Stratigos. I'm a postdoctoral research assistant based at the Scottish University's Environmental Research Centre, and I'm going to talk to you today about some work that I did during my PhD research, which was at the University of Aberdeen, that examined historic drainage programs that removed most of the lochs that used to populate the northeast Scottish countryside. And I'll focus today on the lochs that were in the Dee catchment, and in particular those on the lower Deeside, which might be most relevant to the work that Mesolithic Deeside's been carrying out. I'm going to focus on how we might sort of repopulate those lochs from a paleogeographic modeling perspective, and how that might be relevant for Mesolithic Deeside in the results that they've already generated, and also where we might go forward with this, and how this work might inform future Mesolithic archaeology research on Deeside. So to begin with first principles, it's important to keep in mind where the lochs came from in the first place. And nearly without exception, lochs in Scotland are the result of glacial processes, whether that was the carving out of valleys and basins by the ice as it advanced or retreated, or by the actual wastage of the glacier itself, which left large chunks of ice scattered around the landscape that then became kind of magnets for debris, which created what are known as kettle holes, where depression in the landscape surrounded by debris that then sort of infilled with water. And as I said, very few exceptions to lochs around Scotland that aren't the result of these types of processes. And they, by and large, resulted in two types of lochs. You get very large lochs that sort of infill U or V-shaped valleys. These valleys were carved out by the glaciers themselves, and then have subsequently filled in with water. These are more typical of the central and northern highlands, so think Loch Ness, Loch Tay, Loch Awe. But the majority of lochs along Deeside are not like this. In upper Deeside they are, Loch Mick for instance, but the majority on lower Deeside are of a different character. This is Locke Ord, which is much more typical of lochs in lower Deeside. It's broad and shallow, maximum of maybe about 4 meters. Now, broad and shallow lochs are important ecologically because sunlight can reach the bottom of the loch right across its entire surface area. So that means there's much more biodiversity, which represents potentially a very rich resource for Mesolithic communities. Now, once these lochs have been established and all the ice has melted, there's really only one process which would impact the threaten the existence of a loch, and that is terrestrialization. Now, terrestrialization is a process whereby sediment and nutrients enter into the loch, and if that sedimentation rate exceeds the rate at which sediment is leaving the loch on the downstream end of the loch, it will slowly fill in. This process can be impacted by human activity, most notably deforestation and planting of crops, which sort of exposes more sediment to erosion that ends up going into the loch. And over time, with enough time, this will eventually lead to the loch turning into a bog, and there are a number of examples that you can point to in northeast Scotland of that process, where initially, after the retreat of the glaciers, you had a loch, open fresh water, and through sort of natural or human-aided processes has become a bog. And this was the case right up until just a few hundred years ago. Things changed dramatically in the 18th and 19th century through the implementation of drainage schemes. Now, there were earlier drainage schemes in the medieval period and in the 16th and 17th centuries, but in terms of their scale and prevalence, were very minor compared to what occurred in the 18th and 19th century. Although I will touch upon a couple of instances of 17th century drainage later in the talk. It was really the 18th and 19th century that defines where and what kind of lochs that we find in the Scottish landscape today. You can get a hint as to just how prevalent the practice of loch drainage was, and indeed other wetland drainage, by the two quotes on the left. And those quotes come from the agricultural surveys of Scotland, which are late 18th and early 19th century publications, which aim to promote sort of best practice of the day. And as you can see, drainage was at the top of the list in terms of best practice. The physical impact of this drainage is readily seen across the landscape today. You can see that in the picture here on the right of Spiny Canal. And it's called a canal slightly tongue-in-cheek. It never was meant to, or indeed ever carried any types of cargo or boats. It was purely to drain the Loch Spiny, which is a very large loch just north of Elgin, sat between Elgin and Lossiemouth. And it extends for up to about 6 kilometers and is incredibly deep. It required pumping to get the water into it, because the surface level of the water sits above many of the surrounding fields, and it's still in use today, the system of canals and pumps, in order to keep agricultural land clear of standing water. It was this process of 18th and 19th century drainage that I wanted to quantify as part of my PhD research, in order to examine what impact it might have had on the survival of wetland archaeology, crannogs in particular. To do this, I used the ROI Military Survey of Scotland, which is a really unique map for Scotland. It was the predecessor to the Ordnance Survey, and it covers all of Scotland, all of mainland Scotland, at a scale and detail that allowed it to be used for this analysis. And the analysis was very simple. Simply located every loch on the map. There's about 1,750 of them. And then tracked those lochs through time, through editions of the Ordnance Survey to the present day. And what this did is give a sort of time-stamped data set of where and when drainage was occurring across Scotland. And this was very useful for contextualizing the history of research on crannogs and other wetland archaeology. And it showed that eastern Scotland saw earlier and more intense drainage compared to western Scotland, southwest Scotland in particular, and the central and northern highlands of Scotland saw relatively little drainage. And this is, of course, related to the different kinds of geographies in these regions. Larger highland lochs just simply can't be drained, whereas the broad, shallow lochs of eastern Scotland not only can be drained, but provide rich agricultural land in many cases in the drained areas. Now, the ROI map wasn't absolutely perfect. It does not cover every square inch of Scotland, nor does it cover every square inch of Scotland with equal detail. So there are a number of lochs that simply just weren't mapped at all. The map was produced with very specific aims in mind, to sort of move military personnel around the country. So if a feature wasn't particularly important, it sometimes just got left off. To that end, there are about 20 lochs in the D catchment depicted on ROI, and of course there are, in fact, more than 20 lochs that exist on Deeside. So we can do better than what I produced for my PhD, and which is now published in the Journal of Wetland Archaeology. You can go download this data set. We can do better through adding more detail. That further detail could come in the form of more historic maps. This map shown here is the Pont map. It's produced at the end of the 16th century, so that really increases the time depth of the analysis. And the end of the 16th century is also a period before virtually every drainage program that took place in Scotland. So it's capturing some of those lochs that might have had some amount of drainage before ROI got around to surveying them. And in addition to the Pont maps, there are a whole series of other maps available through the National Library of Scotland that pick up lochs that ROI missed, and also add further detail in terms of the size and extent through time of these various lochs. The loch depicted in this particular portion of the Pont map is the Loch of Park, or the Loch of Drum, and it is one of the main lochs on Deeside that has been drained, and you can see it depicted here in this part of the map. There's a certain amount of sort of getting your eye in for each individual map to sort of figure out what the lochs look like. Sometimes they're not particularly clear. Most of the historic maps that add more detail to the initial ROI analysis come at a time before there was sort of a science of survey. These are really more sort of sketches of the landscape, relational sketches. So a depiction of a loch is a really good indication that there was a loch there, and more often than not, Pont and some of the other early surveyors were very good at showing how they related in terms of directionality to other features, but what they are not good at is showing the actual sort of geometrical accuracy of these features, including lochs. The Royal Military Survey of Scotland was also susceptible to this, although it was sort of at the beginning of scientific survey, and some of the lochs depicted and other features depicted on the Royal Military Survey of Scotland are pretty accurately mapped geometrically. If we want to actually start to plot what these former lochs looked like, we need to add in yet further detail from other sources of data. A really good source of data for this is geologic data, in particular the superficial geology or the soil geology of particular areas. A good source for that is the British Geological Survey Geology of Britain Viewer, which is depicted here, which shows the area of the Loch of Park, and it shows the soils and sediments that are derived, and in this kind of taupey brown color are all the soils and sediments derived from standing water, from peat and lake type sediments. So this is starting to give us an idea of where water used to sit in this landscape, building on the indication of a loch depicted on the Pont map. In addition to these types of soil and geology maps, the Geology of Britain Viewer also allows you to identify geotechnical data from cores in particular. So that's lithographic descriptions of cores, many of which are publicly available and can be very useful at defining the depth of these deposits and the particular character of them as well. In addition to geological data, archaeological data can also be used to help define the former extent of these lochs. Terrestrial archaeology unsurprisingly respects the former shorelines, and the archaeological record can frequently also be used in conjunction with other types of historic documentation that sometimes describes where features sat in relation to the former extent of a loch. So coupling that data together with modern height data, usually in the form of a digital terrain model, can actually begin to plot what the former loch looked like, what its former extent was. In this particular case, the height data that was used was the 5 by 5 meter digital terrain model produced by the Ordnance Survey. And this is what the result looks like. This is the Loch of Park, located between Drumoak and Crathis, about 2 kilometers from Nethermills, where Mesolithic Deeside recovered a really exceptional assemblage of lithics. Before moving on, it's important to keep in mind the approach that I've taken here sort of is to plot a model of the maximum former extent of the loch. So this isn't to say that the loch ever looked exactly like what's been mapped here, but rather this is what the data supports could have been the maximum former extent. So should further data emerge that suggests this wasn't the precise size or shape or extent of the loch, the model would need to change to reflect that. Now, the Loch of Park is interesting in that it's relatively untested in terms of archaeological potential. There is a bit of archaeology recorded in and around this particular basin, but really there's not been much focused work on it. So given its proximity to Nethermills, I would suggest that it probably has very high potential for Mesolithic archaeology. and it's simply a matter of trying to locate it. Now, even if there isn't much Mesolithic activity represented around the shores of this loch, it's worth mentioning that it probably represents a very good case for a good preservation of paleoenvironmental information. One of the key pollen records from along Deeside comes from Loch Park, but this work was done back in the late 60s or 70s and is published as Vassery and Vassery. And this was a time before radiocarbon dating in particular was routinely used on pollen cores. So there's a lot of benefit, I think, in potentially going back to the Loch Park and updating that paleoenvironmental record and that pollen record in particular. The Loch Park is also notable in being, for its size, as much as 220 hectares of open freshwater was drained sometime in the 18th, 19th, 20th centuries. There was a sort of relict, small loch that persisted right into the early 20th century that was sort of finally drained, I think probably when the use of mechanical diggers was employed. However, I think this loch is a good candidate for terrestrialization processes through the Holocene, so it's probable that the former extent of the loch was not quite as large as 220 hectares when those drainage schemes were implemented. But this remains to be tested in the field and could be tested through a pretty straightforward program of coring and a bit of radiocarbon dating potentially as well. But despite its pretty exceptional size at 220 hectares, potentially of open fresh water, it was not the largest loch on Deeside to have ever been drained. That probably goes to the Loch of Auchlossan, much further up Deeside, which we'll talk about now. Loch Auchlossan was first drained in the late 17th century, and this resulted in a substantial portion of the former extent of the loch being removed. And this is significant because it probably occurred before any mapping of the area had been undertaken, and so we don't actually have any historic documents showing the full extent of the former loch. It wasn't until the mid-19th century that a system of additional drains, open channel drains, tile drains, as well as tunneling were implemented to actually remove the rest of the loch. However, even with this very extensive and intensive drainage scheme, you can still see in the modern landscape that there are portions of the loch basin that are still imperfectly drained. And we can see this as well in editions of the Ordnance Survey from the early 20th century. We can see that in this edition of the Ordnance Survey. On the left, the loch is depicted, and on the right, it is not. And I think this might relate to potentially just what season the surveyors were actually in this area. But it clearly shows that the loch was still, despite the immense efforts, reoccupying this basin, at least seasonally. So bringing the data together again for Loch Auchlossan, we can propose a very large extent, maybe as much as 500 hectares for this loch. At this extent, its deepest point would have been around 12 meters in depth, which really points to the incredible efforts from the 17th to the 20th centuries to actually remove this loch. The strongest piece of evidence that supports this very large extent is actually the archaeological record. From within the blue area proposed here, there's not a single archaeological record that predates the 17th century, and that's despite a relatively busy archaeological landscape around this area. Today it's pretty prime agricultural land, so I would find it very surprising if this land was available prior to the 17th century and wasn't used. Stronger evidence beyond that is actually the reclassification of a site called the Howff as a crannog. This is a site that I excavated with some help from Mesolithic Deeside members back in 2015 as part of my PhD research. And on balance, it seems like this site was probably a mound of organic material, timber and stones that is consistent with a crannog. And everything else supports the idea that the loch sat at around 145 meters above sea level, which is the proposed paleo shoreline that you're seeing here. In addition to the excavation I undertook at the crannog, some pre-development work just not far from the crannog excavated what was interpreted as a trackway that sat at the former Loch shoreline, and this once again sits right at that 144, 145 meter contour. The castle, annotated there as well, historically is recorded as having a causeway to it. It's not ever described that I've seen as an island, but the fact that it does have a historic record suggesting a causeway would presume that it is set out on an island. Despite the very large extent and the great depth of this former loch, as far as I can tell, preservation conditions seem to be very poor. That was certainly the case at the crannog that I excavated, and that once again just speaks to the real intensity of drainage. However, in the deeper portions of the loch, there might still be some amount of organic preservation in permanently saturated sediment. So moving back down the Dee, we'll have a look at the Loch Lays. It's depicted here in the 17th century, before any major drainage efforts had occurred, on a Gordon map, which is available on the National Library of Scotland's website. The first drainage attempts are recorded in the early 18th century, and we can actually see that depicted on the Roy Military Survey of Scotland, which shows the outlet burn labelled as a drain. But the loch persisted despite these early drainage attempts, and it wasn't until 1850 when the loch, when the open fresh water was fully removed. The loch is now sort of a bog, and it's unclear exactly how much benefit that 1850 drainage attempt made in terms of increasing the amount of arable land that was available around the loch. Now, many of you probably have walked around the Loch Lays. It's a popular sort of walking destination, and if you have done, you will see the 1850 drainage scheme very clearly. This is it here. Very, very impressive deep drain was cut and stone lined. This is fairly uncommon, but there are a number of other examples of these really impressive drainage ditches that then get stone lined. And this just speaks to that incredible 19th, 18th, and 19th century drive to remove these environments. The former shoreline of the Loch Lays model has been greatly improved by the recent release of LiDAR data sets, over and above what I was able to achieve in my PhD research. And this loch basin has a relatively rich later prehistoric and medieval archaeological record centered around the crannog in the Loch Lays, which I also excavated as part of my PhD. But in addition to the crannog, there was also a logboat recovered from this loch basin, possibly two, in fact. But the one that was definitely recovered had some bronze cauldrons within it, and those are now on display in Crathis Castle. But in addition to the logboats, there might be a record of something more relevant to Mesolithic Deeside in the form of a deer skull of unusual size, which was recorded as being pulled out of the peat within the loch basin when it was drained in 1850. There's been several programs of coring within this loch, and there's good preservation of peat extending up to sort of 6 meters in depth. So it's likely that there's early and mid-Holocene deposits within this basin that might be good for doing paleoenvironmental work. The drain that you saw in the last slide, cut in 1850, drained probably over 50 and up to as much as 70 hectares of open fresh water. Now, the preservation has remained good because despite the drain, the level of the water has remained high enough to keep those organic sediments preserved. So the Loch Lays is one of the better loch basins within Deeside, one of the better drained loch basins within Deeside for preservation. Moving further down Deeside, and in fact just slightly outside of the Dee catchment, we have the Loch of Old Aberdeen, and you can see it depicted here on another of Gordon's maps, this one dating from 1661. The loch was actually drained just the year after, in 1662. And I throw this up there just to illustrate a number of lochs that were actually within what is now the modern city of Aberdeen, which have been completely wrecked and built over by the modern city. The Loch of Old Aberdeen is one of the more exposed. The others are sort of centered in New Aberdeen, closer to the Dee, and we're sort of sitting around where Robert Gordon's school is, Union Terrace Gardens, and of course those are now completely obliterated. So the archaeological and paleoenvironmental potential of these former lochs is much, much lower than compared to, say, the Loch or the Loch Park. A handful of lochs have survived the drainage programs of the 18th and 19th century. Shown here is Locke Ord, although even Locke Ord saw about a meter of its depth taken away during a particularly dry summer in the middle of the 19th century in order to keep the mill at Dinnet going. Other lochs like the Loch seem to have survived more or less unchanged from earlier periods. These lochs represent good potential certainly for paleoenvironmental data and possibly archaeological data as well. The survival of Mesolithic archaeology isn't well recorded around Loch Ord or Loch or most of the other surviving lochs, but nobody's really looked for it either as far as I'm aware. So it is possible that there's good evidence for surviving Mesolithic archaeology in these areas. Modeling former loch shorelines has some implications for the paleoenvironmental and archaeological data that we have. I've been sort of speaking about this here and there throughout, but it's worth flagging up again. These historic drainage programs very frequently result in a common phenomenon seen in paleoenvironmental sampling of loch and bog basins, and that's of intrusion and inversion. This is where later sediment ends up in stratigraphically an earlier position within a paleoenvironmental core or an archaeological site deposit. And these processes occur much more commonly in drained environments. And the reason for that is very directly related to the practice of drainage, where material is literally being moved around the basin. That can cause an intrusion or inversion of stratigraphy. You also, when you bring the water off, you speed up the process of terrestrialization, and that results in greater biological activity in these drier sediments now. Tree species, scrubby wood species, and of course animal species are now sending their roots or digging into the drier sediment, and that's moving material around. And that can have very severe negative consequences for the preservation of this material. Not only is the material drying out, the organic material drying out and decaying, it's also potentially being moved around actively by animals or plants. In addition to sort of problematizing or contextualizing the paleoenvironmental and archaeological data that we have, the modeling of former shorelines can also help us target or protect the archaeology and paleoenvironmental records within these environments, identifying the areas where there might be good preservation of material is very important for developing research strategies or heritage management strategies in these environments. In addition to the more prosaic aspects of why we might model the former shorelines of lochs and the implications that the data set that I've developed has, we can also use it as a skeleton, if you will, for a Mesolithic geography. Putting back that water gives us a frame for and context for the archaeology of the area. For that reason, I've put up this photo of the Mesolithic pit alignment at Crathis, which may very well have had a celestial alignment, but certainly within this landscape it sits not far from the River Dee and between the Loch and the Loch Park. It's undoubtedly the people that dug these pits and used these pits would have been familiar with this landscape, would have been familiar with the Loch and the Loch Park just a few kilometers away. So in addition to contextualizing the archaeology we have and giving a frame of reference for the geography and perhaps how people moved and experienced the landscape, we can also talk about the resources that were on offer in freshwater ecosystems. And this last point about resource availability is really worth underlining. these freshwater ecosystems would have been some of the most ecologically rich environments available to Mesolithic hunter-gatherers in eastern Scotland. And the amount of waterfowl that would have been available, or different types of plant resources that would have been available, would have made these environments key locations within the landscape. Coupled with the very rich resources provided by the River Dee itself, we can imagine sort of how that geography of resource exploitation might have played out at any given point in time during the Mesolithic period. And for that reason, I think it's notable that Nether Mills seems to be this node of Mesolithic activity along the Dee. It sits very nicely within easy range of all these different freshwater ecosystems along the river, up to the Loch Park and up to the Loch Lays, providing good access to all these different resources. So when we think about the Mesolithic archaeology of these freshwater environments, it's worth highlighting the really spectacular and fantastic Mesolithic site at Stockcar in Yorkshire, perhaps one of the most spectacular Mesolithic sites in Britain. Even in this relatively well-drained landscape, which you see in this photo of the former lake basin, fantastic preservation of timber and other organic materials, as well as an incredible lithic assemblage were recovered. In addition to the lithics and the timber, there was also a very large faunal assemblage, which included the very famous deer skull masks from Stockcar. And this sort of shows that Mesolithic communities weren't just simply fulfilling an ecological role within the landscape, but there's a whole culture there, and that is best seen in these very rich wetland archaeological sites. On the drier sites, we get the pits, like at Crathis, and we get the lithics, like at Nether Mills. But if we want to find some of that more texture, some of that finer grain detail, it's going to come from a wet site. And so that is what really underlines the importance of trying to understand the history of land use change that has impacted freshwater environments along Deeside. So moving forward with this work, I think further testing of the former shorelines would be good, adding new data as it becomes available, whether that's LiDAR or archaeological data of sites that give an indication of where the former loch sat. This would all help to refine precisely where we think water sat in this landscape at different periods of time. And this will help improve new efforts to collect paleoenvironmental data from these loch basins. Most of the paleoenvironmental analysis that were undertaken on Deeside were done some decades ago, and there have been massive advances in all sorts of techniques for paleoenvironmental analysis in that time. In particular, our ability to use radiocarbon dating to pin down precisely when major changes and less major changes in the landscape, vegetation cover, human impacts to the landscape have taken place. And that will really help to understand and contextualize what the Mesolithic landscape looked like. And of course, the paleogeography of these lochs also will help us to prospect for in situ Mesolithic archaeology. If there was a Stockcar or something like it in northeast Scotland, we now have a roadmap for trying to find it. That, of course, could be done just by expanding the methods that Mesolithic Deeside are already employing along the banks of the Dee. So with that, it just leaves me to say thank you very much for listening. It's very kind of you to allow me to give you this lecture about the work that I've done over the past few years. Thank you very much.